Now today we will discuss analysis of RL series circuit, right? This is the RL series circuit. R and L in resistance and inductance are connected in series, supplied with a voltage V0. IT is the instantaneous current flowing through the circuit, and this is the key K. On closing the switch, current will flow through this circuit, and we considered that the switch is closed at time t is equals to 0. This has got a significance which we will discuss in this problem. Why we have said that we have mentioned that the key K is closed at time t is equals to 0. Now, after closing the switch, once the switch is closed, what from KVL what we can write? What is the voltage drop across R? If IT is the instantaneous current, then the voltage drop across R, instantaneous voltage drop across R will be R into IT. And what will be the voltage drop across the inductance L? It will be L dit dt. Right, these things you have already know from your basic electrical engineering course. So these drop across the resistance and drop across the inductance. The sum of these two will be equals to the supply voltage, and that is what KVL's Kirchhoff's voltage law says. So it will be L di dt plus RIT is equals to V0. And if I take Laplace transform, this will be L is constant and R is also constant. So you have to have Laplace transform of, you have to know Laplace transform of dit dt. So it is a derivative. And what is the Laplace transform of a derivative? Laplace transform of a derivative is given by, already we have learned about it, that Laplace transform of a derivative. This is Laplace transform of a derivative of a function is given by s fs minus f of 0 plus. What is fs? Fs is the Laplace transform of ft, and what is f of 0 plus? This is the value of ft as t tends to 0. That is the initial value of the function ft. So this is the initial value of the function. So if I use this, then it will be is. Here it is it, so it is is. I have written minus I of 0 plus, minus I of 0 plus R of is. Is is the Laplace transform of it, and this is V0 by s. Why this is V0 by s? That also we have done. What is the thing? See, Laplace transform of a constant C. This is C by S. So Laplace transform of a constant, C is C by S. So V0 is, here it is constant, it is a DC source. It is a DC source that has been considered. So it is constant with time. So this is V0. Its Laplace transform will be V0 by S. Now let us see what is the value of I0 plus. I0 plus is what? It is actually the initial value of I. What is the initial value of I? Before closing the switch is closed at time t is equals to 0. So the initial value of the current, so at time t is equals to 0, the switch has been closed. So there was no, before closing the switch, there was no current that was flowing through this circuit. That means before closing the switch, the inductor has got no energy stored in it. So there was no initial current. That is the significance of writing this, that the switch K is closed at time t is equals to 0, means that before the switch is being closed, the inductor, there was no energy stored by the inductor. So the initial current is 0. The value of it at t is equals to 0 is 0. So this is I of 0 plus is 0. So the current through the inductor is 0 because I0 is 0. So as the initial current through the inductor is 0. So if I simplify this, so this is Ls plus R, Ls plus R, this factor is 0. So Ls plus R into Is is equals to V0 by S. So what is Is? Is will be equals to V0 by S into Ls plus R. So taking this L common, it is V0 by L into what you are left with? You are left with 1 by S into S plus R by L, S plus R by L. So by partial fraction expansion, you have done this partial fraction expansion in class 12, I think, in calculus. Then it can be written as, this factor is written as A by S plus B by S plus R by L. All the factors in the denominator are written by this. So on simplification, this is 1 is equals to A into this plus B into this, and the denominator from both the side will cancel out. So I have written this. So at S is equals to 0, this term becomes 0. So A becomes equals to L by R. So at S is equals to 0, A is equals to L by R. And when S is equals to minus R by L, so this is equals to 0, and this becomes, B becomes equals to, so it is minus R by L, so it becomes equals to minus L by R. Basically, that is the rule for the partial fraction. You find out these coefficients, we find out these coefficients at the roots of this denominator polynomial. So one root is at S is equals to 0, the other root is at S is equals to minus R by L. So the coefficients are obtained by putting successively by putting the value of the roots in this equation. So that is how we have splitted this function. So Is becomes this. Now the problem is, the question is why we have done so. Because we are doing so because we want to find out the value of it. My solution is, my problem is to find out a solution for it, not for Is. That is, I want to find out the current as a function of time, not as a function of S. So what I have to do, I have to take inverse Laplace transform of Is. Inverse Laplace transform of it gives Is, and inverse Laplace transform of Is will give you it. So it is equals to Laplace inverse of inverse Laplace transform of Is. So in order to find out inverse Laplace transform of any function, of function of S, what we need to do is that we need to express each individual factor in such a way that we know that this factor is a Laplace transform of which time function. Each factor is a Laplace transform of a certain time function, and then by looking at remembering those formulas, we can simply express it again by taking inverse Laplace transform of Is. That means, what is the 1 by S? 1 by S is the Laplace transform of what? 1 by S is the Laplace transform of ut. because C by S is the Laplace transform of the constant C. So if C is 1, then it becomes 1 by S. Again also for ut, this is the Laplace transform. So if you remember the Laplace transform of unit step function, this was unit step function, and Laplace transform of unit step function was 1 by S. See, it is 1 by S. So I have to express these factors, this product, this form of expression into terms for which I already know each term is a Laplace transform of which time function. So 1 by S is 1, that means ut. And what is the Laplace transform? Which time function has a Laplace transform of this? You see, which time function has a Laplace transform of that? Just a minute. If it is e to the power at, then it is e to the Laplace transform is 1 by s minus a. So if it is s plus a, it will be e to the power minus at. So inverse Laplace transform of 1 by s minus a is e to the power at. Similarly, inverse Laplace transform of 1 by s plus a will be e to the power minus at. So for this reason I have taken L common here. For this reason I have taken L common just to express this expression, this factor as s plus a, where a is r by L. So this is plus. So you have 1 minus e to the power minus RT by L, and whole multiplied by ut means that the circuit, this IT starts from t is equals 3 greater than equals to 0. That means the circuit was initially relaxed. The initial current I of 0 plus is equals to 0. So I have multiplied this expression with ut just to signify, with ut means with unit step function, just to signify that IT, that means the current through the circuit will flow after the switch is being closed at time t is equals to 0. Now at t is equals to 0, the exponential term is 1, this is 1. So it is, if this is 1, then this is 0. So it is equals to 0. At time t is equals to 0, it is equals to 0. At time t equals to infinity, that means after an infinitely large time, e to the power minus infinity is 0, then it becomes v0 by r. That means it becomes constant. v0 by r means current becomes constant, which is the steady state current through the circuit. That this constant current is actually this current, instantaneous current. This current is a function of time, you see. So after a sufficiently large time, the current through the circuit will become constant, and its value will be equals to v0 by r. Basically, this is the maximum value of the current that can flow through the circuit, right? So at time t is equals to L by r, if I put time t is equals to L by r, then this L will cancel, r will cancel, it will become e to the power minus 1. E to the power minus 1 means 1 by e. 1 by e means 1 by 2.732, like that. So it will be 0.37. 1 by 2.732 will give you 0.37. So it will be 1 minus 0.37 means 0.63. Sorry, 0.63. Then final expression of IT will be 0.63 v0 by r. This is known as the time constant of the circuit, generally denoted by Tc or tau c. The time constant. Then what is the definition of time constant of a series RL circuit? that is the time constant of RL series circuit, is the time in which the current grows to 63% of the steady state value. This is the steady state value. 0.63 means 63% of the steady state value. Time equals to L by R. The current in the circuit will grow to 63% of the steady state value. So what will be the current response of this circuit? If I draw this current IT along y-axis and T along x-axis, so this is 0 and the current will grow exponentially. And if this red line is V0 by R, so after infinitely large time, this current will almost approximate to V0 by R. And this is TC. At this time, this value of this current will be 0.63 of V0 by R. At time t is equals to TC, it is 0.63 into V0 by R. So this is how the response of the current through the RL series circuit looks like when it is plotted as a function of time, right? So this is how the series RL circuit is analyzed.